So, good morning, everyone, and welcome to this special lecture. We are dealing with gravitation, and in this class, we'll try to wind up this chapter in whatever ways it is possible. That would be my first priority to clear this chapter up. But before clearing this chapter up, there was a task that was given to you. There was a question that was given to you that you had to do. What is the status of that question? Anyone tried it? Anyone got it? Huh? Or everyone was chilling out? Anyone was chilling out? Okay, okay, we can't do this. Is that so? Anyone tried that question that I gave? No, sir. We did not try, sir. Yes, sir, or no, sir? You had to find out. You had to find out what? The escape velocity from the center of the earth, not from the center of the earth, but from a distance r by 2 from the center of the earth. Did anyone find it out? Say either say yes or say no.
No, sir.
Why, sir? You were all attending marriage functions of your near dear ones, huh? Because this is the time of marriages. Everyone is getting married. Were you attending marriages?
No, sir.
No. Okay. Then did the earthquake come in Hyderabad that your house got destroyed and you did not get time?
No, sir.
So that also did not happen. Okay. I thought that an earthquake came and everything got destroyed. There was a thunderstorm there. The lights were out of your place and you could not find time to study. Was that the case? No, that was also not the case, na? Okay, that means you did not do it just because you did not do it. Great. That is a great reason not to study, that we did not feel like studying, sir. So now you have the time to do it. I'll give you 5 minutes and no more excuses. I need the answer or I need why you can't do it. Out of these two things, I'll need one of those things. So I'm giving you 2 minutes and I need the answer for this question. Am I clear?
Yes, sir.
So I am giving you 2 minutes, exactly 2 minutes. Do whatever you want to do, but get me the answer to this question. Tell me how this question is to be done. At least you must have the thought process, if not anything else. So tell me, I'll give you 2 minutes to think about it. Take a deep breath, think about the question, and tell me. Maybe the same question is going to come in your JEE. You never know. This could be a question from JEE Advanced. Gravitation has not come, I think, in the previous 1 or 2 years. So there is a high probability that gravitation can come. Okay? 2 minutes you have. Root GM by 8R. How did you get root GM by 8R?
Sir, I put in, like I have used the work energy theorem
Okay. From where to where?
from that point r by 2 to infinity.
Okay. Then what?
Like the initial velocity may be v and kinetic energy at point A is half mve square.
Okay. Work done from A to infinity by gravity is equal to change in kinetic energy. Okay. What next? Hmm. Do it step by step. So how did you find out work done from A to infinity by gravity?
That is change in potential energy, sir.
Not change. That is Difference in potential energy. Potential
Difference of
energy at A minus potential energy at infinity. So I can find it out by this. Is equal to final kinetic energy is 0, initial kinetic energy is half mv square. Yes. What is the potential at infinity?
it is GM
What is the
by
potential at infinity?
0, sir.
0, sir. What is the potential? The only thing that you had to find out was the potential at the point A, and that was the entire reason the question was given. What is the potential at point A? That I don't know, sir.
Sir, it is GM by 8R
GM by 8R. Plus or minus?
minus.
How did you get GM by 8R?
Sir, integration of GDR.
Great. You had to integrate it. Batao. And I did not tell you how to find out the potential by integration. And you had to integrate it. By God ki kasam. Too much of task, isn't it? Too much of task that you had to find out. Too much of a task, isn't it? Too much of a task that you had to do. Too much of a task. You could not do this. Too much of a task that a similar question was done with a similar thing here. Too much of a task. You have to integrate it by God. Oh, God save us. This day is the last day on this planet. God save us. 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 God will not save us because I have already told you how to find out the potential. It is minus G M by 2R cube into 3R square minus distance square. Distance of this from the center is R by 2 square is equal to minus half V square. That is what you had to do, my dear friends, and that was the reason that question was given, and I knew that you have forgotten. Everything that we do, if you forget it, well, what will happen? Only God knows. Anyways, I will hope for better days. This is definitely not one of your prime days. Everything that can come has been already told to you. If you don't use it, I can't help it. This is the way you have to do it. You have to find the potential inside the sphere. You don't have to integrate it because I've already given you the results after integration and differentiation and trigonometry and whatever. You don't have to integrate it. You just have to put the value of x in that formula as r by 2. That was it. Nothing else you had to do. And from here, you will get the value of a. Can you now tell me what is the value of v that you are getting from here? Yes. What is the value of v that you are getting from here? What is the value of v that you are getting from here?
Under root 11 GM by 4R.
Under root 11 by 8 gm by r. That is the answer that you should have got. And you should have got it on your own. Sad part is I had to do it.
Sir, It is 4, no, sir.
What 4 no, sir? Oh, sorry, 4 hours. The sad part is you should have done it, not me.
Sir, in denominator it is 4 or 8, sir.
In denominator, I 4 hours. 11 by 4, not 8. 11 by 4. We get this, yes or no? Huh? Do we get this question, yes or no?
Yes, sir.
Chalo, I wish you luck for this one and I hope you can get this one. So this is this is the next question. Calculate the velocity with which a body must be thrown vertically upwards from the surface of Earth so that it may reach a height of 10 r. Height of 10 r. Remember, where r is the radius of Earth. You can give your answer in terms of g, m, and r. I don't want you to calculate it, the entire thing. The body has to reach a height of 10 r. Your time starts now. So how are you supposed to do this? You make Earth. This is just for theatrical purpose. Radius of Earth is r. You throw a particle from the surface of Earth. Velocity v. This is point A and this is the highest point B. And the distance of this highest point, because it is given as height, is 10 r. It may reach a height of 10 r. So this is 10 r. Now I can apply either work energy theorem or I can apply law of conservation of mechanical energy. From point A to point B. What is the potential energy at point A? Minus G mm by R. What is the kinetic energy at point B? At point A, half mv square. At this point, when it reaches, because it is the maximum height, the velocity has to be 0. What is the potential energy at point B? Minus G mm by how much R?
NR, sir.
NR. 11 r. The distance from the center of Earth is 11 r plus 0. You have forgotten the formula of potential due to a sphere. Anyways, you must remember that formula. Now you solve this and you will get the required answer. Yes, anyone got the required answer? V, I think, would be coming as the answer that I have is 20 by 11 gm by r. That is the answer that we were looking at. That is the answer that we were looking at. Do we understand this? Yes or no? Do we understand this?
Yes, sir.
What was the fault with what you were doing? Yes or no?
Yes, sir.
Okay. Then let me give you one more question based on this. This was a question that came in the IIT that I gave. I think so. And I could solve it in the examination hall. Can you do it in the classroom? Distance between the center of two stars is 10 A. The masses of these stars are m and 16 m, and their radii are a and 2a respectively. A body is fired straight from the surface of the larger planet to the smaller planet, or larger star towards the smaller star. What should be the minimum initial speed to reach the surface of the smaller star? Diagram is not given in this question. Diagram was not given in the original question. How are you supposed to do this? How are you supposed to do this question? You have to throw a body from a smaller planet to a bigger planet. Tell me one question, and it has got nothing to do with physics. Is it easier to send a body from Earth to Moon, or is it easier to get it back from Moon to Earth? Which is the easier task? Sending it from Earth to Moon, or getting it back from Moon to Earth? Earth is bigger, Moon is smaller.
Getting back from moon to earth, sir,
Why so, sir?
has escape velocity of moon is very less, and coming onto earth, the gravitation can help us.
The first statement you said was not correct. Escape velocity from Moon has got nothing to do with it's coming on Earth. When it is escaping Moon, it is going to infinity. It's not coming to Earth. You should not use that term. Now again try. Is it easier to send something from Earth to Moon or from Moon back to Earth? And you would have seen all these the Apollo missions where we landed on the Moon. To get onto the Moon, we need a big rocket. But from coming back to Moon, only a small capsule was enough. Why it was enough?
As coming down, gravitation helps us.
Why does the gravitation and Moon also exerts gravitation?
As gravitational energy due to earth is more than that of moon.
Gravitational force of Earth is more than that of Moon, and that is why it is easier to come back from Moon to Earth rather than going from Earth to Moon. Now they're asking you what is the minimum velocity with which you must project a body. So now you will have to think up till what point should I send the body? Up till what point should you send the body so that it reaches the smaller body? And how you got to do this? How you got to do this? Remember this. This is the diagram of sending the body from the larger planet to the smaller planet, larger star to the smaller star. How much velocity you should give? You should give it that much velocity that it reaches the surface of the other planet, or you give it some other velocity. You need to send that body up till which point? You need to send the body up to the point where their gravitational forces are equal, because after that point, the gravitational force of the other star will pull it towards it. itself. Do we understand this?
Yes, sir.
So you don't have to actually send it to the surface of the other star. You just have to send it to a point where their gravitational forces are equal. Do we understand this?
Yes, sir.
So you just have to send it till the point P. If it just reaches the point P, after point P, the gravitational force of the bigger star cannot do anything. The gravitational force of the smaller star will pull it towards itself. Bigger star is Earth, smaller star is Moon. So you can see Moon is smaller, so the point is closer to the Moon. So if you have to send it from Earth, you will have to send it to a larger distance because you have to escape the gravitational pull of Earth and get into the gravitational pull of Moon. So it is difficult. It will require more energy for you to project that body so that it reaches the gravitational field of Moon. But from Moon, even if you give a very smaller velocity, you can reach that point which is very near to the surface of Moon. The Moon is very smaller compared to Earth. So if you give it that much point, you reach that much point from Moon, the gravitational pull of Earth will pull you towards it. And that is why for all these Apollo mission, they had big rockets when they wanted to send the astronauts on Moon, but after Moon, they only had a small capsule. In fact, when they landed up because of gravity in a very small capsule, and they ended up in the Atlantic or the Pacific Ocean. You know this, yes or no? You did not need a spacecraft for that. Gravitational pull of Earth was good enough to get them back. But they had to reach this point P where the gravitational force of Earth becomes more than the gravitational force of the Moon. Do we understand this, or this has gone above our saying bye bye?
Understood, sir.
Then I have told you everything. Now I need the result. What is the velocity that you need for this body to go back to go on the moon? You have 2 minutes. So let me solve this question for you. First of all, we have to find out the position of this point P. And if you remember, I have already given you the formula to find out the position of this point P. Anyone remembers it? Anyone remembers that formula that I had already given to you? No, sir, we don't remember. Anyone remembers it? Yes or no? No, sir. No one remembers it. That is the problem that you have. The only thing you should forget is the habit of forgetting things. But that is not the thing that you forget. The thing that you forget is that you forget everything, but not the habit of forgetting things. I've already given you this result, and you had solved a question based on that result also. That is what I call smart hard work. If you look at your screens now, you find that formula which I had already given, the point where the gravitational forces are equal. And we had done a problem as well on this. So this is the point where the gravitational forces are equal, and you need to send the body only up till this point. So now coming back to the question, if I had to find out, if I had to find out this distance r, what will be the value of this distance r? This distance r will be root over capital M divided by root over capital M plus root over 16 times of M multiplied by D. This is as simple as it gets. If I put the values, this r will come as 2a. So this distance will come as 2a from this point, and from the center of the bigger star, it will come as 8a. So now what I need to do, I just need to apply law of conservation of mechanical energy from A to B, A to P. So I now apply Lockme. from point A to point P on the surface of the planet. On the surface of the planet, what is the total energy? So the total energy is minus GMM. Sorry, the mass is 16m. So minus 16m into small m divided by 2 times A, which is the radius of this circle, radius of this sphere, plus half mv square. That should be equal to the kinetic energy at point P, because it just needs to reach this point. The kinetic energy or the velocity at point P is 0. We just have to find the potential energy at point P. Now at point P, both both small m and capital M and 16m, this body and this body both are creating potentials. Remember in this question. So in the first part, I only wrote the potential due to the first sphere. That is wrong. So that is where you can make a mistake. So remember, you have to also write the potential due to the other sphere. The potential due to the other sphere is minus G into M divided by 10A. I hope you understand what I am writing here. Yes or no? No, yes.
Yes, sir.
So you have to find out the potential due to both the spheres, both the stars. Do we understand this? And then similarly, you have to find out the potential energy due to both the stars. Sorry, this is not 10A. Yes, this would be 10. No, that would be not 10A. I have made a mistake here. This would be 8A. The distance from the center of the star to this point is 8A. So, do we understand what we are doing here?
Yes,
This
sir.
type of question should not come. Only one part will come. I'm just giving you, if it just comes, you must be careful. Now, this must be equal to the potential at the point P. What is the potential at the point P? Minus G into M divided by the distance is 2A from the smaller planet, minus G into 16M into M divided by 8A. From here, you will get the value of your point velocity at this point. What are the things that you can make a mistake? Point number one, you must understand that you have to find the potential due to both the shells, both the spheres. You have to find the potential at both the spheres at this point. I actually wrote it from point A. I should have written it from point A here. So you have to find the potential due to both the spheres at point A. You have to find the potential due to both the spheres at point B. Remember, both the spheres are creating potential at that point. Do you get my thing where you can make a mistake? And you have to find this point P as well. So just remember this. Solving this, the answer that I have is the answer that would be coming. And remember, the answer is, in this case, 3 by 2 root over 5 gm by a. The point where we are going to make a mistake, first of all, we have to understand that we have to make it reach a point where the gravitational force is 0. That is point number one. And second, we have to find the potential on the surface of the first sphere and at the point P because of both spheres, not because of one sphere. Do we understand this?
Yes, sir.
These are the two things where you can make a mistake if you be careful. And I don't think that question can come again exactly in the same way, but yeah, they can ask you in terms of multiple choice. This was a question from a JEE where JEE was of a different level altogether. Okay, it had less questions, and it had the difficulty level was more, and this paper on physics was for 3 hours. Get my point? And at those time when I gave this JEE, there were three papers: maths 3 hours, physics 3 hours, chemistry 3 hours. So that is from the 3 hour paper. Okay, so such questions are very less likely to come because it will require some understanding, and if you make a mistake, you will end up with the wrong result. Okay, we get this. Shall I move on to the next question?
Yes, sir.
And this is a question that came in the previous year JEE, and we don't normally see a question where they ask you the time, how much time it takes to reach, and this is one of those questions in which that time is asked. So a body is projected vertically upwards from the surface of Earth with a velocity sufficient enough to take it to infinity. So with what velocity it would be projected? It would be projected with the escape velocity. That is one part of the question. But the next part of the question is this: what is the time taken by it to reach the height h? If it has to reach a height h, how much time it will take? Now, such questions are very rare. So I'll just give you 2 minutes to think about this, and then we'll solve it. And remember how we have solved it, because it will require again a time consuming question that will require you to integrate the entire thing, and you might make a mistake in that integration. So I'll give you 2 minutes to write this question, and then we will solve it. Try it in the time if you get. Let's not waste much time into it. Let me just solve the question for you, and you see how this to be done. Again, whenever time is asked, it will require integration, so be very careful. So, and this is point number one. Oops. And I project it from this point with a velocity which is equal to the escape velocity. Do we understand this? Yes or no?
Yes, sir.
And it has to reach a height. Let us call that height as r or h. Let me call it as h. It has to reach a height h. The velocity at this point is v. Okay. Now let us take it general. If it is at a height h, I am taking the velocity as v. Okay. So how are you going to get this? Since they have asked it for height h, let me take a general case where I take the height as r. I will find out a general case, how much time it will take to reach the height r, and then I will integrate it. Now, how do I get this? I first apply Lockme from point 1 to any general point 2. So, what do I get from applying Lockme? Half into m into its velocity square. Its velocity is 2 gm by r. That is its kinetic energy. The potential energy is minus gmm by r. Its kinetic energy at the highest at the point is half mv square, and the potential energy is minus gmm upon r plus small r. Do we understand what I have done here? Yes or no? Everyone understands this?
Yes, sir.
Now, from this equation, I can find out the value of v. Because these two terms are equal, they will just get cancelled. Yes or no? I can find the value of v in terms of r. So I will get v as under root of 2 gm upon capital R plus small r. Do we understand this? Do we understand this, beta?
Yes, sir.
Okay. Now this v is nothing but the rate of change of r with t. Yes or no?
Yes, sir.
From here, you have to integrate and find the value of time. So how will you integrate? Root over 2gm is a constant that will go on this side. dt will go on this side. dr into root over r plus r will go on the other side. You will integrate time from 0 to t. Are you getting my point, beta?
Yes, sir.
And this r is to be integrated from 0 to h. Are you getting it? This r has to be integrated from 0 to h. I will leave the integration part and I will tell you the answer. The answer is option D, and that is what you will get after integrating it. Do we understand this, bacha? It will just require integration and for you to put the limits and get the answer. We will get the answer in terms of gm and r. They have given the answer in terms of small g. So again, you have to put small g as gm by r square. Okay. So this is how this question was made. Again, this was one of the difficult questions and we don't expect such questions to come anyways. This is a question from JEE Advanced. Whenever such a question comes where they ask you time, then you remember you have to find out velocity v as a function of h, and in most cases if this question comes, it will come with escape velocity only, because that is the way, that is the condition in which you can find out this velocity as a function of time easily. Otherwise, if I give it any other velocity, the question becomes way too complicated to integrate, and you will just be losing a lot of time. So remember this. Do we understand this?
Yes, sir.
Okay. And I think this is a simple integral. You can integrate this. You can put r plus r as y or z and then integrate it. You know how to integrate it, yes or no? This is a simple integral. Anyways, shall we move ahead? Do we understand what we have done up till now? The only concept that we have to understand is the law of conservation of mechanical energy, or if you want to do it, by work energy theorem, work done by all forces. In this case, only gravity will be the force, will be change in kinetic energy. You just have to find the potential difference and multiply it by the mass. Everyone understands this, yes or no?
Yes.
Then you can write the next heading, which is circular motion of planet, circular motion of satellite, circular motion of a satellite around a planet. Circular motion of a satellite around a planet. Do you have any idea how these satellites are launched?
Yes, sir.
How these satellites are launched? How these satellites are launched? Hmm? Any idea?
How means about what you are asking?
I mean, what is the process of launching of a satellite? How a satellite is launched? So you put the satellite in a spacecraft, rocket, and the rocket takes it to a certain height. And then from that height, if this is your Earth and I have to launch a satellite, what do? I, I place a rocket. This is my rocket. And I place the satellite in that rocket. And then this rocket goes up to whatever height I want to put the satellite. And from that height, if I call that height as h, and from that height, it launches it with a horizontal velocity v0. And if the velocity is correct, The satellite will keep on moving in a circular orbit around Earth. Do we understand this? This
Yes,
is
sir.
how satellites are launched. And this is exactly what is shown in the figure, but in the figure they have not shown it height wise. They are basically showing a satellite moving around Earth. The distance from the center of Earth is given as r. Do we understand this? What I am saying?
Yes, sir.
Have you understood this, Pakka?
Yes, sir.
How a satellite launched. Now, when a satellite is in the orbit, this r, the distance from the center of Earth, this r is known as orbital radius. This r is known as orbital radius. So basically, this orbital radius is the distance from the center of Earth. This v naught is known as orbital velocity. I can calculate this omega naught, that will be equal to v naught by r. This omega naught will be known as orbital what? Orbital angular velocity. And then I can find out time period t naught, 2 pi by omega. That will be known as orbital time period. Do we understand what I'm talking here? Do we understand what I'm talking here?
Yes, sir.
Pakka? So I'll give you 2 minutes to draw this diagram. Diagram is understood by everyone? Okay, 2 minutes. So basically what you need to know now is you will have to find out the values of all these quantities that are given here. The only thing that you know is probably the orbital radius, how far it is from the center of Earth. That is the only thing that you know. Then how will you find out the other quantities? Yes, how will you find out the other quantities? If you know the orbital radius, how will you find out the other quantities? How will you find out the other quantities if you know the orbital radius? I will show you another diagram. And I think you can see the diagram now. So, another snapshot. So, how do you find out this velocities? This is the orbital velocities. So, it has to move in circular orbit. Someone has to provide it with the centripetal force. Who is going to provide with the centripetal force? Centripetal force is mv square by r. Who will provide it with the centripetal force?
Gravitational.
So, gmm by r square. From here, you can get the orbital velocity as gmm by r. We understand this? Yes or no? You can also write it as under root of gm upon r plus h. Yes or no?
Yes, sir.
You can also write it as, and the more the number of ways in which you remember, it is good. You can also write it as under root of gr square upon r plus h. Yes or no? Or you can also write it as r times under root of g upon r plus h. Anyone understand this? Yes or no? No, yes. Anyone understands this? Then you can find out the omega. Omega is the orbital angular velocity. It is simply v divided by r. So you divide v by r in all these things and you will get the answer. So the first value will be gm. You can divide it now. So let me not write it. You can divide it now. The second thing that you can find out is the time period, and time period is 2 pi divided by v into r. Yes or no? So you will get the time period as 2 pi r into under root of r by gm. Or you can write it as 2 pi under root r cube by gm. Or you can write this time period as 2 pi under root of r plus h the whole cube divided by gm. Or you can write it as 2 pi under root r plus h the whole cube divided by gr square. I hope you understand the different ways in which I am writing this. Yes or no? No, yes. There's one more great way of writing this, and if you can remember this, it is all only coming from this 2 pi root over r by g into 1 plus h by r raised to the power of 3 by 2. Now, why I'm giving you all these values? Sometimes, if you can remember these shortcuts, you can solve one or two problems very quickly because of these shortcuts, and that is the only reason I I am giving you all this, just because you can solve the problems quickly. Nothing else. Do we understand this?
Yes.
Okay, then you can write some. Have you noted it, this round? Have you noted it down, beta?
Done, sir.
Then you can note down some important points about this orbital velocity. As you can see, this orbital velocity does not depend on the mass of the satellite. It only depends on the mass and the radius of the planet. Yes or no?
Yes.
So even if two satellites are of different masses, but they are on the same orbit, when I say same orbit, that means the distance from the center of Earth is same. They will have the same orbital velocity. Orbital velocity does not depend on the mass of the satellite, but it depends on the mass of the planet around which that satellite is moving. Do we understand this? Do we understand this, everyone? Yes or no? Everyone is following this? Everyone is following this, beta? Yes or no? Am I audible, visible to all of you?
Yes, sir.
Okay. For a given planet, mass is same. Orbital velocity is inversely proportional to the radius. That means the farther you place the satellite, the lesser will be the orbital velocity. The farther you place the satellite, the lesser will be the orbital velocity. Now there is a term which is known as near Earth satellites or near planet satellites, and this is a very important concept. Orbital velocity of a satellite when it revolves very close to the surface of the planet. These type of satellites are known as near planet satellites, or you might have heard this word near Earth satellites. Do you understand near Earth satellite? They are very close to the surface of Earth. In fact, your International Space Station is very close to the surface of Earth. On a clear day, if you have a small telescope, you can actually see that. It's only 24 kilometers above the surface of Earth. So they are known as near Earth satellites. And for near Earth satellite, you can see in place of r plus h, you can just put r, and the value of near orbital velocity for a near Earth satellite is 7.9 kilometers per second, approximately 8 kilometer per second is the orbital velocity of a near Earth satellite. I hope I am making sense and I am not talking nonsense. Yes or no? Yes or no? Do we understand this, beta?
Yes, sir.
Okay. Now, for any satellite which is close to Earth, the orbital velocity is root over gm by r, and this orbital velocity you can see is escape velocity divided by root 2. This is escape velocity divided by root 2, or your escape velocity becomes root 2 times of the orbital velocity of any planet, of any satellite which is very close to Earth. Have you noted it down, bacha?
Yes, sir.
Now, one more important concept, we can easily get it, but you can just note it down, because I have seen question coming on this concept. Sometimes they give you that gravitational force is not proportional to 1 by r square. It is proportional to 1 by r raised to the power n. And then they ask you what is the orbital velocity. Remember, if the force varies as 1 by r raised to the power n, mv square by r is equal to gmm by, instead of r square, it will become r raised to the power n. So your orbital velocity will come as 1 by root over r raised to the power n minus 1. The concept remains same. The concept remains same. Do we understand this? So these are the important points about the orbital velocity VO. Has everyone noted down these points? Number one, orbital velocity is independent of the mass of the satellite. Number two, it depends on the mass of the planet. Number three, for a given planet, it is inversely proportional to 1 by root over r. For a near Earth satellite or a near planet satellite, you can put in place of small r, you can put capital R, and it becomes orbital velocity for a near Earth or near planet satellite. Then you can have a relation between orbital velocity and escape velocity. Orbital velocity, escape velocity divided by root 2. Do we understand all of these points? Yes or no, no or yes? Yes or no, no or yes?
Yes, sir.
Now the next thing is to note down some important points about the time period, and that will lay foundation for the next and the last topic of this chapter. Important points about time period. Can we move ahead in life? Have you noted it down, the orbital velocity wale points?
Yes, sir.
Have you understood those points? Now, similar, the points would be similar. Some points would be exactly similar to the points of orbital velocity, because this time period is coming same as orbital velocity. So you can see this time period of the satellite does not depend on does not depend on the mass of the satellite. It is exactly same as what we had discussed. Yes or no? No or yes? Huh? Now this time period is proportional to root over r cube. So you can have this legendary equation, t square is proportional to r cube. Have you seen this equation before? Yes or no? No or yes? Yes or no? No or yes?
Yes, sir.
Where have you seen this equation? T square is proportional to r cube. Then time period for a near Earth satellite, nearby satellite. So what you do in a nearby satellite, instead of small r, you put a capital R. You get this? So the for a time period of a satellite which is near Earth, becomes 2 pi root over r by g. Everyone is noting it down, I hope. The more the number of ways in which you can note them down, it will be easier for you to solve the question and get the answers quickly. Can we move on to the next one? In terms of density, you can also write the same formula of a nearby satellite, and the formula for a nearby satellite in terms of density looks like this. Remember, these are not different formulae, just gm by r cube by gm. We just put the mass of earth in terms of density of earth or density of the planet, nothing else. We have not done anything extravagant. I hope you understand the meaning. Yes or no? No, yes. Then again, I've seen questions where they have given gravitational force is proportional to 1 by r raised to the power n. In that case, the time period ka formula becomes n plus 1 by 2. Time period will be coming proportional to n plus 1 by 2 r raised to the power. Have you noted it down, bacha? Then there is a last concept of geostationary satellite. We will discuss this concept in the next heading also, but here it is coming, so I will discuss this. Now, Earth is rotating from west to east. If there is a satellite which also rotates from west to east, and if the angular velocity of that satellite is same as the angular velocity of Earth, the satellite will appear stationary relative to Earth. Such satellites are known as geostationary satellites. We will do a couple of problems on geostationary satellites as well for us to understand the concept of geostationary satellites. We will do that. Let us quickly move on to some questions so that we can understand what we have learned. And the faster that you do questions, the faster I can move on to other and more questions. Yes. Can I move on to questions, my dear friends?
1 minute.
Okay, I'll give you time. Let me know once you are done. Let us then move on to a simple question, and this is the question. It's a straightforward question. Give me the answer fast so that I can move on. I can move on with the other question. The question is pretty simple. Two satellites A and B go around a planet in circular orbits. Radii are 4r and r. When I say radius, it is from the center of Earth. If the speed of the satellite A is 3v, what is the speed of the other satellite? Yes. And the answer is Yes, do we have an answer? You don't have an answer? Shall I do it? Okay. Shall I do it? Orbital velocity of a satellite is gm by r. So you can see it is inversely proportional to root over r. So I can write v1 will be equal to gm by root over r1. I can write v2 as root over gm by r2. Do we understand this or not?
Yes, sir.
So what is the answer, sir?
C, sir. C and D.
Huh?
C and D, sir.
I find the ratios. v1 by v2 will be equal to root over r2 by r1. Root over r2 by r1. Now if I call v1 as 3v, so 3v divided by v2 will be equal to 4r by r. Actually, this question is it's not the ratio is reversed, so I did the same mistake. It is r by 4r. The satellite which is farther will have lesser speed. The satellite which is nearer will have more speed. That is the mistake that you have made. So my v2 will come as 6v. Yes or no? Do we understand this? Or you have done the same mistake as I was doing, but then I saw the values and I thought, okay, I thought that answer is given wrong. But then I thought, and I looked at the values and I said, okay, it is right. So the answer is 6v. Do we understand this? We understand this, yes or no?
Yes, sir.
Remember these questions. Now comes the next one. If the gravitational force between two objects were proportional to 1 by r, where r is the separation between them, then a particle in circular orbit under such force will have its orbital speed equal to what? Proportional to what? Here the gravitational force between the planet and the satellite is not proportional to 1 by r square. It is proportional to 1 by r. What will be the speed proportional to? What will be the speed proportional to? And the answer is I've already given you the answer, but still you can't do it. So if you don't remember it, the centripetal force is mv square by r. That will be equal to g mm by r. So r and r will cancel and v will be proportional to r raised to the power of 0. And that is the answer that we are looking at. I had given you here also in this shortcut. I had given you. Please have a look at this pink thing which is underlined. If the gravitational force is proportional to 1 by r raised to the power n, velocity will be proportional to 1 by root over r raised to the power n. Okay, this is written in the wrong way. It should be written like this. I did not check it. Should be written as 1 by r raised to the power n minus 1. Okay, so correct it. It's probably written in the wrong way. Do we understand this?
Yes, sir.
Okay, it's written in the wrong way, so I have corrected it now. I did not see it. Can you move on to the next question?
Yes, sir.
This is the next one. This percentage change wale problem come a lot. You can call them as problems of gravitation, or you can call them as problems of error and measurement. A satellite is moving around the Earth with a speed v in a circular orbit of radius r. If the orbital radius is decreased by 1%, what will be the effect on speed? I'll give you 2 minutes to do this. I hope you get me the answer. It will increase by 0.5%. That is correct. Now, how do you get this? Now remember, if there is anything, A is given as b raised to the power x, c raised to the power y, divided by d raised to the power of z. Now, if there is a equation like this and you get a percentage wala question, then remember, percentage change in A divided by A, the percentage change in A will be x times percentage change in B. Remember, the power comes here, plus y times percentage change in C minus z times percentage change in D. Do we understand this? So whatever is the
Yes.
denominator become minus. That means if one increases, other decreases. You got this? Now based on this, V is given as root over Gm by R. G is not changing, M is not changing. So I can write I can write V as proportional to 1 by root over R. That means R raised to the power of half. So change in V divided by V will be equal to minus half of change in R divided by R. Do you understand this?
Yes, sir.
Minus means if one is increasing, the other is decreasing, and so on. So remember this. Let us move on to some question on this one. Do it fast. Periodic time of a satellite revolving around Earth's surface at a height equal to r is how much? At a height equal to r is how much?
Sir, it is option C, sir.
Option C is correct. You must just remember what you must remember. Time period is 2 pi root over r plus h, the whole cube, divided by g into m. Yes or no?
Yes, sir.
So it becomes 2 pi, height is h, so it is 8 r cube, height is r, divided by, instead of gm, I can write gr square, and so you get your answer. Yes or no? Everyone got this? 2 pi outside, 8 by GR inside. Sorry, 8 by 1 R will remain on the top, 8 RG. So 8 will come out, it will become 2 root 2. 2 root 2 multiplied by 2 becomes 4 root 2 pi. So I think the answer would be this one, B. Yes or no? Do we understand this? Yes or no? Do we understand this?
Yes, sir.
And this one. Get me the answer first. Yes. Do we have the answer for this one? Hmm? Do we have the answer for this one? This is the simplest question in the entire universe. Does time period depend on the mass of the satellite?
No, sir.
T square is directly proportional to R cube. You cannot forget this in your entire lives. This life or the other life. So T1 by T2 square will be equal to R1 by R2 cube. And from here, you should get the answer. What is the answer? One radius is R, the other radius is 2R. Should it take so much of time? This is R divided by 2R cubed. So it is 1 by 8. So T1 by T2 is 1 by 2 root 2. That is the answer. Is it difficult for you to understand, beta? Or I have given you so much of formula that you have got confused? Is that so?
Sir, no, sir. Here in the formula, R is from the center of the earth, no, sir.
Yes, beta. So okay. The in the question it was given at a height R. Okay. Sorry, I did not read it. So one is at a height of 2R, the other one will be at a height of 3R. Right? That is what you want to say? See, from the center it is given. A bit. So the language of the question is like this. At a
Okay,
height
okay.
of R from the center.
Okay, sir.
Okay? So remember this.
Yes, sir.
Okay. ठीक है चलो one more small formula that you must remember is the height of a satellite from the surface of a planet. Height of a satellite which is moving in a circular orbit from the surface of the planet. Sometime this question comes, so you must be remembering this formula. because this formula may help you in getting the answer very quickly. So this is your Earth. The radius of the Earth is r, and then you have a satellite which is moving with a velocity v naught. It is moving in circular orbit. I'm not drawing the entire circle. You understand the meaning, na? It is moving in
Yes,
a
sir.
circular orbit. Oops. The height of this is h. Now we can easily find out this height h if other things are known. I will just show it to you. This time period of this satellite is 2 pi under root of r plus h the whole cube divided by gm. Yes or no? Or instead of gm, I can write it as 2 pi root over r plus h the whole cube divided by g r square. Yes or no?
Yes, sir.
If I just move around and find the value of h, this is the value of h that you will get. Remember this, t square gr divided by 4 pi square cube root minus r. This is the formula that you will get if someone asks you the value of the height h in terms of the time period. So bacha, please remember this. Please remember this.
Done, sir.
Okay, the next heading that you are supposed to write is known as the energy of a satellite in a circular orbit. Energy of a satellite in a circular orbit. Energy energy of a satellite in a circular orbit. Energy of a satellite in a circular orbit. And again, you can use the same diagram. Uh, Satellite is moving in a circular orbit. Let me just get you that diagram. A satellite is moving in a circular orbit. It has energy. What type of energy it has? What type of energy it has?
Mechanical energy.
It has mechanical energy, which is a combination of potential energy and kinetic energy. Yes or no? No or yes? So it has both potential energy and kinetic energy. Its kinetic energy is half m v naught square. Yes or no? Half m v naught square. Yes or no? Half m v naught square. Yes or no?
Yes, sir.
Please say na sir, otherwise I don't understand whether you have heard me or not.
Okay, sir.
Okay, so it has a kinetic energy half m v naught square, and we know the orbital velocity is gm by r. Yes or no? So we can write it as gm by 2r. Yes or no?
Yes, sir.
We can also write in terms of L. What is L? And remember this. What is L? L is the angular momentum. This L, my dear friends, also remember it in terms of L. This L is the angular momentum. What is the angular momentum of this satellite while it is revolving in this orbit? It is mv into r. Oh, mv into small r. Do we understand this? Because it is moving in a circular orbit. Yes or no?
Yes, sir.
So you can write this kinetic energy in terms of angular momentum as well. Then it has got potential energy. How much potential energy it has got? Minus G M by R. Yes or no?
Yes,
So
sir.
I can write it as minus L square by 2 minus L square by M R square. I'm writing it in terms of angular momentum. Then I write the total energy, which is the mechanical energy. The total energy, which is the mechanical energy, will be minus G M by 2R. That will be equal to minus L square by 2mr square. What you have to note here is this mechanical energy is negative of this kinetic energy, and this is equal to potential energy divided by 2. Do we understand this?
Yes, sir.
Everyone understands this? Yes or no? No or yes?
Yes, sir.
Now, this total mechanical energy is negative. This total mechanical energy is also known as the binding energy of the satellite. This total mechanical energy is also known as the binding energy of the satellite. Because this energy is negative, the satellite is bound to Earth. It cannot escape Earth. It is bound to the Earth because of this negative energy. If someone gives it this much of energy, it will leave. It will leave the circular orbit and say bye bye to Earth and go. Do we understand this? This binding energy of this satellite to a planet is exactly similar to something that you have done in chemistry. Have you done something in chemistry like this? Huh?
Yes, sir.
The loosely bound, last electron loosely bound, how much energy is required, or binding energy, ionization energy, how much energy you need to ionize. This is same thing, binding energy, ionization energy. The positive of that energy becomes ionization energy. Do we understand this, or this is going about a thing? Bye bye. Bye bye, sir. I'm going. So the thing that you must remember that this thing is exactly similar to the chemistry mein electron moving around the positively charged nucleus. Yes or no? No, yes.
Yes,
Huh?
sir.
Huh. Then I'm going to give you some more important points about all these, because one of these points is going to appear in your exam. So what are the essential conditions for satellite motion to move it in a circular orbit? The center of the satellite orbit should coincide with the center of Earth. Plane of orbit of satellite should pass through the center of Earth. So then it can move ding 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 around Earth. It does not move with this music that I have given. It was just special effects, but it moves around the center of Earth. Do we understand this, or this will go on above it saying bye bye? Have you noted it down? Have you noted it down, bacha?
Yes, sir.
Same points written point wise so that you can remember them. The kinetic energy, the potential energy, or the total energy of satellite depends on everything. It depends on the mass of the satellite, it depends on the mass of the central orbit, and it depends on the radius of the orbit. I hope everyone understands this. Note it down. The more the ways you note it down, the more the number of ways you note it down, the better it is, because you will be remembering it, because you have this habit of forgetting things. The only thing you have to forget is not to forget things. But the only thing that you forget is that you keep on forgetting things. Yes. Have you noted it down, beta? Then comes this legendary diagram between energy of satellite, which is moving in a circular orbit. And as you can see, that you don't draw this diagram here. We will take it. We can take it. This diagram is not drawn correctly. Diagram is not drawn correctly. We will do it. Remember one point here, that the total mechanical energy will remain constant. Do we understand this? Yes or no? Because it is only under the action of gravitational force, so the total mechanical energy will remain constant. I hope you understand this. Then this is a concept of binding energy. If you want to note it down, you can note down the concept of binding energy. The total energy of the satellite is negative. That means it is bound to Earth. It is bound to Earth. If you give it that much of energy, it will say bye-bye to Earth, which most of the things that I say bye-bye to you. You don't understand bye-bye. The satellite will say bye-bye to Earth and say bye-bye, I'm going. Have you noted it down, Becha?
Yes, sir.
Yes or no? No, yes. Now, sometimes you might encounter a question where they ask you what is the work done in changing the orbit of a satellite. The satellite is moving in a orbit of radius r1. You have to change the radius to r2. So how do you do it? To find out the work done, you just find out the change in the total energies. Remember, total energy is minus gmm by 2r. Do we understand this? So you just subtract the two energies and you will get your answer. Do we understand this? This is the work done in changing. In changing what? Work done in what?
Changing the orbit of satellite.
Changing the orbit of a satellite. Work done in changing the orbit of a satellite. Work done in changing the orbit of a satellite.
The answer.
Well done, sir. Then we move on to the next heading. And the next heading is known as geostationary satellite. Geostationary satellite. Yes, I will give you chance for you to show me your skills. What is a geostationary satellite, my dear friend? Huh? You don't know, sir. That is the simplest answer. Yes. Huh? No idea? The idea or no idea?
This satellites whose angular velocity is equals to angular velocity of Earth.
And whose sense of rotation? Okay. So, a geostationary satellite, Earth rotates from where to where?
West to east.
West to east. A geostationary GS satellite also rotates from west to east. The omega for that satellite is same as omega for Earth, which is 24 hours. This satellite will appear stationary. This satellite will appear stationary with respect to Earth. Such satellites are known as geostationary satellite. Now remember the time period t square will be equal to 4 pi square divided by g into m into the radius cube. So if I put the value of time as 24 hours for this, for Earth, if I put time as 24 hours, if I put time as 24 hours, I will get the value of this r approximately equal to 6.6 times the radius of Earth, or the height of this satellite will be 5.6 times the radius of Earth. We understand this? Yes or no? No or yes? This satellite, my dear friend, is known as a geostationary satellite. A geostationary satellite, my dear friends. A geostationary satellite. Do we understand this?
Yes, sir.
Huh? Now, for this geostationary satellite, for Earth, everything is fixed. Its distance from the center of Earth is fixed. Its time period is fixed. Its angular velocity is fixed. Its linear velocity or orbital velocity is fixed. What are the important points that you must remember about a geostationary satellite? So these are the points that you must remember about a geostationary satellite. It rotates in the equatorial plane. What do you mean by equatorial plane? A plane which contains what? The equator of Earth. So this is the equator of Earth. So it must rotate in an equatorial plane. plane that contains the equator of Earth. Do we understand this? Yes or no? Yes or no? Its height from the surface of Earth is also fixed, approximately 5.6 r. Its angular velocity and time period should be same of Earth. Its rotational direction should be same of Earth. Its orbit is called the parking orbit. The orbital velocity is also fixed. That is 3.1 kilometers per second. I will give you 2 minutes to note this down. Then let us move on to the last topic. Not the last topic. Topics are still remaining. And this is known as a polar orbit or a polar satellite, or some people also call it sun synchronous satellite. What is a sun synchronous satellite or a polar satellite? It has orbit like this. See, this is your equatorial plane, plane containing equator. The geostationary satellite moves like this. Dug, 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 dug. The polar orbit is like this at an angle of 90 degrees. Sui, 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 sui. Equatorial like this. Sui, 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 sui. Polar is like this. Sui, sui. These polar satellites are also known as sun synchronous satellites, my dear friend. Do we understand this? So if some question comes of this polar satellite, then you must remember that a polar satellite moves like this. Everyone understand this? Yes or no? No, yes. Huh? No one is saying, huh? Are we there? Or we have gone? Then comes the last topic of this chapter. And what is the last topic of this chapter? Huh? What is the last topic of this chapter? No one knows this. Well done. Huh? No one knows this. Welcome to the end of this chapter. Welcome to the end of this chapter. And how does the end of this chapter begin? The end of this chapter begins with the last thing, but sometimes it could have been the first thing that we study. Kepler law. Kepler. Newton once said, I sat on the shoulders of some giants. And that is why he became Newton. One of those giants, he named 3 giants. I don't remember the name of the other 2. I will tell you by Googling it out. One of those giants was Kepler, and Newton became Newton not because of Newton, but because of who? Astigmatism? No. Because of Kepler. Newton became Newton because of Kepler. It is an hypothetical thing that he saw an apple falling down and he discovered gravity. Kepler had already given him enough material to work around with. It was Kepler who was the Kepler was the one which made Newton what he was. Kepler. What is Kepler's law? Huh? Now, before going on to Kepler's law, we must understand something about something which is known as this thing. What is this thing? Huh? What is this?
Ellipse, sir. Like it is
understand ellipse.
rotation of Earth around Sun.
Now, Kepler laws consist of things about this ellipse. So first of all, you have to tell me what do you know about ellipse, my dear friends. Yes. Now you have time to show me your talents. If you can't show your talent, then I will show mine, and you will have to hear all those jallikati baate from me. So tell me, what do you understand by ellipse? What do you mean by ellipse? If there is anything that you can enlighten me on. Now, what is ellipse? Huh? You don't know, sir. What is ellipse, sir? How do I tell you, sir? This is the first time we have heard the term ellipse. How will I tell you, sir? Yes, my dear friends. Is this the first time you have heard the word ellipse? Huh? Is this the first time you have heard the word ellipse? Arey, say na. This is the first time you have heard the word ellipse. So now this gets converted into a maths class. Yes. Say, what do you know about this gola that I made? Ellipse has not been covered in your maths class.
Yes, sir, it is covered.
Yes, then you know more than me. What does an ellipse have? What is this known as? What is this known as? Amitabh Bachchan or Shah Rukh Khan? What is this?
Sir, it is a
Semi-major axis.
semi-major axis.
Okay. What is this known as? Ramcharan.
Semi-minor axis.
Okay. What are these two? Mahesh Babu.
Foci.
How much is the distance of this from here? Rajnikant.
It's A by E.
Na 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 na. So we know so much about ellipse that we don't know the distance of the focus of the ellipse from the center of the ellipse. Minus AE. This is plus AE. I read about ellipse. I think in the year 1997 was the last time I saw an ellipse. This is minus AE. This is plus AE. Okay. So far, so good. Now, what is this E? What is this E? Huh? I don't know, sir. Please don't ask me.
Eccentricity here.
Oh, chalo. And how do I find the eccentricity of an ellipse?
Under root 1 plus B by
1
A
plus or 1 minus? Is it
Sir,
more than 1 or less than 1?
Sir?
It is 1 plus or 1 minus? Eccentricity of an ellipse.
Sir, it's plus, sir. Eccentricity of hyperbola is minus.
Pakka? Minus? Minus? Minus or 1? Minus or plus? I mean, I don't think I'm asking you the question correctly. What do you mean by eccentricity something? Eccentricity means how are the major and the minor axis there, right? And again, I ask you, what is the eccentricity of an ellipse?
Under root 1 plus B square by ఇది కూడా చెప్పడానికి లేదురా
When did you study ellipse, by the way? Just asking for my knowledge.
in 12th class.
Now, I mean, in this class, ellipse has not been covered in maths.
No, sir.
What is going on in maths then?
In maths, quadratic equations, complex numbers, sequence and series.
Algebra is going on. Trigonometry done. Okay. Eccentricity means, how it is. What is the eccentricity of a circle?
One, sir. Zero, na? Sorry, okay. Zero, sir.
Zero is the answer. Eccentricity of a circle is zero. It is not eccentric. The center coincides with everything. Semi-major and semi-minor axes are equal. Eccentricity of a circle is zero. Okay? कोई बात नहीं. It happens. I have made more funny mistakes in my life, and I keep on making them. Eccentricity of a circle is zero. Eccentricity of an ellipse is less than 1. Eccentricity of an ellipse is less than 1. Okay? Write it down. Write it down, everyone. Eccentricity, value of E for a circle is 0. For an ellipse, for a parabola, eccentricity is 1. Between 0 and 1 lies the eccentricity of ellipse. Greater than 1 is the eccentricity of a hyperbola. All these are known as conic sections because they are part of a cone. They are sections of a cone. Okay. The formula for eccentricity of an ellipse is what? Eccentricity of an ellipse for a parabola is for a ellipse is what I'm concerned with. Root over try it again now. 1 minus b square by a square. That is how we calculate the eccentricity of an ellipse.
Sir, when it differs, no, sir, like B greater than A greater than B.
I'll give you a tight slap and then you will understand. B is always semi-minor axis, which is always smaller than A. That is why it is known as minor axis. Otherwise, it will be known as major axis. Okay? So remember this. B is the semi-minor axis. A is the semi-major axis. Eccentricity of an ellipse is 1 minus b square by a square. Nothing in this universe can change it. Okay? Do we understand this?
Yes, sir.
Okay. Now, if I talk about this distance, and let me call this distance as R1, what will be the value of this R1?
Sir, it is A plus minus A plus AE.
R1 will be equal to A into 1 minus E. Okay. And if I call this distance as R2, because this is the closest and the farthest distance from the focus. And if I call this distance as R2, your R2 will be A into 1 plus E. Do we understand this, everyone? Okay, I think that is good enough for me to start ellipse. Do we understand this one, everyone?
Yes, sir.
Pakka na?
Yes,
Okay,
sir.
remember this, don't worry. Now, as soon as we move on to Kepler's law, the first thing that you should understand, that is the first Kepler law, and that is known as law of orbits. Everyone knows this law of orbit? Yes or no? Huh? Kepler's laws. First law. Kepler's law. First Kepler's law. What is the first Kepler law? Law of orbits. Kepler first law is law as law of orbits or law of orbit. What is that first law? All planets will move in a uh, yes, I should not write this. I should give you like this. That is better. All planets move around the sun in elliptical orbit, having sun as one of the focus. So the motion of any planet around sun would be in an elliptical orbit, but it would be like this. But they can also move in circular orbit. Some planet can move around the sun in a circular orbit because circle is a part of an ellipse. Circle is a special type of an ellipse. So I mean, you may find someone moving in a circular orbit, but it is very rare. The only planetary object that we have found out moving in a circular orbit is what? Do you know? The only,
Pluto.
huh?
Pluto.
That is our own Chanda Mama. Tour ke, puye pakaye poor ke. The Chanda Mama of ours is the only planetary object that we have found which is moving in an exactly circular orbit. No? That is why some people say that it is not a natural satellite, it is an artificial satellite set up by some aliens around Earth so that they can keep a track of what is happening on Earth. Anyways, that is the first Kepler law. All planets will move in a elliptical orbit. You may have a circular orbit as well, but in very, very rare case. Then we move on to Kepler's second law. The first law is known as law of orbit. The second law is known as law of areas. The second law is known as law of areas. Any idea? Huh? Any idea what this law states? This law states that a line joining any planet to the sun sweeps equal areas in equal intervals of time. The line joining planet to the sun will sweep equal areas in equal intervals of time. If I take these two areas and if I say the area here is A1 and the time taken here is T1, area swept here is A2, time taken is T2, then your Kepler's second law states, and I am going to write it in many ways, dA by dt is constant. Now this dA by dt, rate of sweeping of area, is also known as areal velocity or areal speed. Areal velocity of a planet around sun is constant. Do we understand this? Yes or no? No or yes? Do we know this? Yes or no? No or yes?
Yes, sir.
Now this instantaneous areal velocity can also be found out by this formula, half r square into omega. This instantaneous areal velocity can be found out by this formula also, half r square into omega. Areal velocity of a planet around sun remains constant. Do we understand this, or this has gone above our head saying bye bye, bye bye, bye bye? I can state this in this way also. I can write A1 by T1 will be equal to A2 by T2. Do we understand this? Yes or no? Huh? Do we understand this? Yes or no? Now, how does this come? How does this phenomena come? This phenomena comes because of the old friend coming, LOCAM, law of conservation of angular momentum. The angular momentum of planet around the sun, around the angular momentum of the planet about the center of the sun, about the center of sun is constant. Why it is constant? Because the only force acting on it, the only force acting on it is the gravitational force of sun, and this gravitational force of sun passes through the center of the sun. Do you see this diagram? Do you see this diagram? So if I calculate the angular momentum of this particle at any point, the angular momentum of this particle L vector at any point, this L vector at any point will be constant about the center of the sun. Do we understand this? Yes or no?
Yes, sir.
So at any point I can write M into V. Sorry, I should not write it as M into V. I should write it as R cross P. The angular momentum L, that will remain constant. Magnitude wise, if I write MVR sine theta remains constant. Do we understand this? Now, it can be proved that this areal velocity dA by dt can be written as L divided by 2m, and since L is constant, this dA by dt is also constant. Do we understand this, bacha? Yes or no? No or yes? Huh? Are you noting it down?
Yes, sir.
Very important pointers here that I am giving you. So this second law, which is law of areas, can also be written as LOCAM. This is law of conservation of angular momentum. Have you noted down everything, bacha? Have you noted down the diagram? Yes or no? No or yes?
Yes, sir.
Huh? Pakka? Kacha pakka, pakka, pakka. Hmm? Noted down? Yes
Yes,
or
sir.
no?
Done, sir.
Done, sir. Then one more thing, sir. Remember the area of an ellipse. Area of an ellipse is pi times AB. Area of an ellipse is pi times AB. Remember this. Area of an ellipse is pi times AB. Area of an ellipse is pi times AB. Do we understand this? Do we understand this? Have you noted it down? Arey, have you noted it down?
Yes, sir.
Okay. Then I can give you this question, and probably this question will help you in understanding how are you going to use this and keep it as a safe deposit. This is the question coming up. Question number 1, let me call it. Suppose a planet is revolving around the sun in an elliptical path given by this. Find the time period of revolution of this planet. Angular momentum of the planet about the sun is given as L. How will you do this? How will you do this? Tan, tanan. Dig, 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 tan, tanan. I'll give you 2 minutes to think about this. So how are you supposed to do this? dA by dt. What is dA by dt? Huh?
L by 2m, sir.
L by 2m. That's it. The total area is pi AB divided by total time period is T. Get the time period of revolution of a planet around sun. Time period of a revolution of a planet around sun is 2 pi mb into A divided by L, my dear friends. So short and sweet answer. You can't get a better answer than this. This is the time it takes for any planet to move around the sun. And if you put the values of Earth for this, you will get 365 point something, something, something. Something, 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 something. So remember, this is the time period of revolution of any planet around the sun. Have you written this, everyone?
Done, sir.
Then the third law of Kepler is known as the law of time periods. Time period T square is proportional to what? Huh?
R cube, sir.
What R? What is R? It's moving in an elliptical orbit. It's moving in an elliptical orbit. So what is R? Semi-major axis cubed. The time period is proportional to semi-major axis cube. This is known as Kepler's third law. Law of time periods. The first law is known as the law of areas, the law of orbits. The second, law of area. The third one, law of time period. Do we understand this? Yes or no? No, yes. Huh?
Done, sir.
Done, sir. Then fatafat solve these 3 problems, sir, so that I can move ahead in life, sir. Fatafat give me the answer for this one. The distance of a planet from a sun is 5 times the distance between the Earth and the sun. The time period of the satellite is how much in terms of years? Simple question that should not require rocket science. Even though we are dealing with gravitation, we are still not dealing with rocket science. Rocket science is rocket science, and yes, my dear friends, anyone with an answer?
కూడా 10 చేస్తే నాకు నిజంగా రివర్స్లో ఉండాలి సో 9 నుంచి ఒకసారి 8 నుంచి ట్రై.
Yes. Answer for this one. No one knows it. Taking so much of time, I'm sure you are not able to get the answer. Then I will do it. How will I do it?
Sir, it is option A, sir.
You have taken centuries to give me the answer. This answer should not have been done in a century. It should have been done in 4 or 5 seconds. T square is directly proportional to A cube. So T1 by T2 whole square should be equal to A1 by A2 whole square. Should you take so much of time to do this, beta? Huh? No. No. So I can write T1 as T2 into A1 by A2 raised to the power of 3 by 2. Distance is 5 times. It's a simple question, yeah. Simple question. Not expected. Anyways, if you give me the answer, then I'm surprised. I'm not surprised when I don't get the answer. Okay, but I always keep on saying that students are like cash vouchers. Sometimes the cash voucher may not work. Just because not something is wrong with the cash voucher, something is wrong with putting the code. So I can keep on trying again. Ah. The planetary motion, the aerial velocity of the position vector of a planet depends on the angular velocity omega and the distance of planet r. If the correct option for the aerial velocity is tan tan. And the answer for this one is, my dear friends, huh? We don't know, sir. We are new in the town, sir. I've given you all possible combinations of this. The problem is, even if
Sir,
I
D
give
by
you, even
DA
if
by
I
D.
give you so much of time, you are still taking 15 hours to solve this question that should have been done in less than 2 seconds. Because if you are taking time for doing questions of this nature, well then, I don't know what to say. And the answer is,
dA by dt equals is directly proportional to omega r square.
should not have taken so much of time to do this, beta. I've
Sir,
given you everything that is possible
we are
in this.
1 second late, sir.
No, not 1 second late. I had waited enough. I only start my philosophical language when I get this, when I have lost all hopes. Then only I start that lecture. Question number 4. So before I start the lecture, give me the answer. The distance of Neptune and Saturn from the Sun are really dig. Assume that they move in circular orbits. Their periodic times will be in the ratio. Tan tan tan. Dig tan tan. Dig tan tan. This is the background music I'm giving for your What should I say? For your motivation. Yes, that is the right word. Motivation. To motivate you. To extract an answer out from you. Is there any possibility of an answer anywhere that I can get from you? And the answer is
10 root 2, sir. Sorry, 10 root 10.
good. Pressure of time is important because you have to do this in a given time, and if you can't do it in the given time, that is of no use. Chalo. I don't think I need to explain this. Yes or no? No or yes?
Yes, sir.
See, I told you, students are like cash vouchers. Sometimes the cash voucher may not work. Not because the cash voucher is faulty, it's because the code that I put was faulty. It's a long code, na? So sometimes, I have got weak eyesight. So sometimes I miss the code. And this is the next one. So before getting into a conversation, let us move on and solve this question. A planet is revolving around the sun in an elliptical orbit. You can see sun is there. The correct option is dung 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 dung. And this should not require rocket science. Even though we are doing questions of rocket. Yes, my dear friends. Any hope? No hope. Get hope. Is an answer coming from anywhere? Huh?
Option B, sir.
The time taken in traveling from DAB.
Sir, E is less than, sir. DAB is less than BCD.
That is the correct option. And how do you find it out? Time taken
Sir,
depends. Yes.
simply area, sir.
Simply area, sir. So from B to D, you join these two lines. This is the area that it is going to travel. But if you want to do it for the other side, the area is this much. dA by dt is constant. More area, more time. Well done. Do we get this, or this has gone above our thing? Bye bye.
We got it, sir.
You see, I always keep on telling you, students are like cash vouchers. Sometimes the cash voucher may not work. It's not because of the cash voucher being wrong. It's because of the code that is being wrong. Now I'll give you some important shortcuts. Remember these because these may help you in dire circumstances. So, important points about elliptical orbit. Now, remember, any question that comes in the elliptical orbit, it will be coming basically on 2 points. One point, which is the closest to sun, is known as the perigee. Do we understand this perigee? The closest to the sun is perigee. Let us say the velocity here is v1, and the farthest point is apogee. Velocity here is v2. Do we understand this? Yes or no? These are the 2 points that you must remember. Now, any question that comes in elliptical orbit will have to be done by 2 things that you must remember. The first concept that you must remember is lock me. Lock me means law of conservation of mechanical energy. If I take any point here at a distance r, let us say that it will have, the sun will have a the planet will have velocity v, you can always apply Lockme. You can always apply Lockme. You can always apply Lockme. And remember, half mv square minus g mm by r will be constant. Do we understand this?
Yes, sir.
Right? Everyone understands this? Now this will be equal to minus gmm by 2a. Remember, the total mechanical energy of a satellite which is moving in an elliptical orbit is given by minus gmm by 2a. Will you remember this? Will you remember this?
Yes, sir.
You can also write this as minus gmm upon r1 plus r2, where r1 and r2 are the distances of the apogee and the perigee from the center of the sun. Do we understand this?
Yes, sir.
This will again be equal to this will again be equal to half m1, half m into v1 square minus gmm by r1. Do we understand this? I've applied this at the perigee. That will be equal to half m v2 square minus gmm by r2. Have you understood this, or this has gone above our head saying bye bye, sir? Do we understand this?
Yes, sir.
Now, at any point, the second thing that you are going to apply is Lockme. Lockme. Right? Lockme you have applied. The second thing that you will apply will be
Locam.
Tam. M V R sine theta at any point will be equal to M V1 R1 will be equal to M V2 R2. Do we understand this? Do we understand this? Yes or no? No or yes? Okay. Now, this angular momentum is constant. So you can just remember the value of this angular momentum at any point will be equal to, you can find it out from any of these formulae. The general formula, you can write it like this. M into R2. M into R2 under root of, no one is going to ask you this, but this is what I just want you to keep it in your safety deposit somewhere. R1 plus R2 multiplied by R2. That will be coming as your angular momentum. I've already given you the formula of time period, 2 pi m AB upon L. Remember AB where there's what? Semi major and semi minor axis. Do you remember this?
Yes, sir.
I'm giving you all these formulae. The only formulae that are remaining are the velocities v1 and v2. So I have this formula with me. I also forget it. So I'll just copy it down from what I have done before. So this is root over 2g, 2 was what? Okay, correct. 2g m into r2 2gm into r2 into r1 plus r2. Let me check this. I hope that I'm not making a mistake here. If I just make a mistake somewhere. 1 minus E upon 1 plus E perigee is apogee. V1 should be more. So this should be correct. R2 into V2. Okay, correct. Correct. I was just confused. So I just thought that I will just check it, because if I just make a mistake in R1 and R2, you will end up in trouble. Now, this formula can also be written in terms of eccentricity. So if a question comes based on eccentricity, this is how you can write it. 1 plus E upon 1 minus E. 2 GM. Sorry, not 1 GM. Okay, now if I have to write V2, if you remember any one of this, you should be able to recollect the second one. So here it goes R1, here goes R2 into R1 plus R2. I always get confused with this formula, so I've written it down in a sheet of mine, so that without any garbada, I can give it to you. And as you can see, V1 is greater than V2. And
Sir, V1
this,
and V2 in terms of eccentricity are same, sir.
oh, sorry. See, I told you now I make a mistake. It's the reverse of this. 1 minus E upon 1. Okay. So this is nothing but equal to M into V2 into R2, which is same as M into V1 into R1. So no matter how you write it, you will end up with the same result. Okay. So this is all that you need to know about any question that can even remotely come in your JEE. Even a question comes remotely in your JEE, it will be covered. It will be covered by these formulae. Okay, do you understand? Everything, V1 and V2, they would ask. I have written it in all the possible ways that are possible. I have written it in terms of eccentricity. I have written in terms of R1 and R2. They can ask you angular momentum. I have written angular momentum in terms of R1 and R2. They can ask time period. I have written time period in terms of A and B, that A and B. And you must remember the relation between R1 and R2 and A and B. Right? So just write that relation as well. 2A will be equal to R1 plus R2. We know this, right? The distance between the 2 points is 2A, and that is equal to R1 plus R2. R1 is the shortest distance and R2 is the longest distance. So I have given you everything in every possible way, in every permutation and every combination that they can give you a question. And again, those questions will only come in a JEE Advanced. They will not come in JEE Mains. In JEE Mains, you will find question like this. So fatafat, give me the answer to this one so that I can wind up this topic once and forever. The maximum and minimum distance of a comet from a sun are this and this. Its velocity at the nearest point is this. What is the velocity at the farthest point? Apogee, perigee, nothing else. Perigee is the nearest point. Apogee is the farthest point. Yes, can I have the answers? Yes, I'm still waiting.
1 minute.
1 minute has taken too many minutes. Minimum and maximum distances. Yes, I have given you sufficient time. So m v1 into r1 shall be equal to m into v2 into r2. v1 is the velocity at the nearest point. r1 is the distance of the nearest point. You have to find out the speed at the farthest point. So v2 will be equal to v1 r1 by r2. v1 is 60 multiplied by r1 is 1.6 into 10 raised to the power 12 divided by 8 into 10 raised to the power 12, and the answer will be 12 meter per second. That is the answer that I was looking for. Do you understand this?
Yes, sir.
And again, the voucher has not worked. But again, that must be because I put the code wrongly. So I give one more last chance for the last question. Same question, but not in values in terms of d1, d2, v1, v2. A planet moves around the sun at a given point P. It is closest from the sun with a distance d1 and at a speed v1. At another point 2, Q, it is farthest from the sun at a distance of d2. What is the speed? And you don't have the option, so sorry for that. I will present the options as well, and the correct answer is
C, sir.
d1 v1 divided by d2 v2. As I told you, most of the questions that you are going to get will be on this perigee and apogee. Perigee, the value is v1, distance is r1. Apogee, the value is v2, distance is r2. And you just have to remember locam, and you just have to remember law of conservation of mechanical energy at any point. I understand the number of formulas that I have given you is much. This is because there is no point of me deriving all those formulae. How are these formulas are derived? By these two concepts only. I will apply locme, I will apply locam, and then I will derive these formulae in terms of the given quantities. There is no need of wasting that time. Remember, the total energy of the satellite is minus gmm by 2a. The time period is this, and the angular momentum is this. If you even remember this much, you will be able to derive all those formulas. But again, these questions are only supposed to come in a tough JEE. I've hardly seen any question on elliptical orbits in a JEE. But you might get them, and if you get them, it will be one of these formulae that you will have to apply. So if you can remember those formulae, put them on your study table, and you would do nicely as well. That brings us to an official end of this chapter on gravitation. We are not going to go back to elliptical orbits, but the rest of the chapter will be covered once again in the chapter on electrostatics, which would be coming, I think, after 15 or 20 days. Once we are done with the other topics, then we will go back to electrostatics, and you will get a chance to revise and revive. So that's it from my end for today's class. I hope you enjoyed it. Take care. God bless you all. Bye bye, everyone.
Thank you, sir. Sir, what will you